Greetings of the day, dear students. Today in this class, very important topic where most of the students will feel it as very difficult to do the problems using nodal analysis. And I will simplify all the steps which are present in the nodal analysis, and I will explain it to you clearly. And please have a notes and pen with you, dear students. Wherever you come across important points or problems, please take down those problems, right? Yeah, now by the time we complete this topic, you will understand the nodal analysis, and we will discuss some important examples. I will tell you what are the different steps in the nodal analysis, and I will explain the process of nodal analysis taking an example. This example in a step-by-step, very detailed manner, we will discuss how to find out the node voltages using the nodal analysis. And also, while doing that, sometimes you will come across unknown equations to be solved. To solve or to find out the unknowns, if it is two equations, we can solve it easily. If there are only two variables, here in this context only v1 and v2 are there, we can solve it easily, two equations. But in some problems you will come across three equations, three unknowns will be there. Then we have to find out using the matrix inversion or Cramer's rule method. And we will also discuss clearly that the matrix inversion or Cramer's rule method to find out the unknowns, right? And this is one more example. Level of difficulty is increased, right? Here we are having three nodes. In this context we will get three unknowns, and the size of the matrix will be 3 by 3 like this. Slowly we will go into the 3 by 3 matrix, and how to find these unknowns v1, v2 and v3 using this matrix determinant, by finding out the determinant of the matrix. And also we will complete this example step by step, and at last we will see one more example. So by the completion of this topic, I will make you familiar to do these three examples, right? I will understand the nodal analysis, right? Yeah, observe, we can say this nodal analysis indirectly as an application of two laws, dear students, and we are going to apply two basic laws. That is, one is the Kirchhoff's current law and the other one is the Ohm's law. Simply to say, Kirchhoff's current law, okay, algebraic sum of the currents, okay, at a node is equals to the 0, n equal to sum 1 to n, or sum of the entering currents is equal to the sum of the leaving currents. That is one basic law we will follow. Other one is the Ohm's law, to find out the V directly proportional to I and V equal to Ri. From this, if somebody asks you current, then what we will say, V divided by R. These two basic laws are important to apply the nodal analysis. I repeat again, which two laws we will use, dear students, to apply nodal analysis? We have to use Kirchhoff's current law and we have to use Ohm's law. Clear? Yeah. Now, for what sake we will do this nodal analysis? Nodal analysis, for what sake? In order to find out the node voltages. In order to find out the node voltages for a circuit which is having some n nodes, then we will apply this nodal analysis. Now, dear students, observe, for a given circuit, okay, if there are some 4 nodes, out of those 4 nodes, one node is selected as a reference node. This point is important. One out of n number of nodes, one node is selected as a reference node, and the now remaining n minus 1 nodes are called non-reference nodes. One node is the reference node and n minus 1 nodes are the non-reference nodes. The moment you get to the problem, you first indicate the node numbers. For example, if a problem is given like this, in this context, how many nodes are there? This is one node where it is a joining point of 2 or more elements. If there are more than 2 elements, you can call it also as a junction. Here at this point, how many elements are getting joined? IS1, R1 and R2 are joined at this point, then this is a node. Observe this point. At this point, how many elements are joined together? 3. IS1, R3 and R2. 3 elements are joined together. This is one more node. Can you identify the third node in this diagram, dear students? Where is the third node? Where is the third node? Yes, you are correct. See, this IS is joined here, and this R1 is joined here, and this V2 is joined here, and this is joined here. All these together form one node. You can take it as a 0th node, reference node. So total 3 nodes are there in this diagram. What I want to say is, the first step, you please identify clearly the nodes. Out of n nodes, you take one node as the reference node, and with respect to that reference node, you indicate the remaining nodes. Give the numbering 1, 2, like that. You continue. So far clear? Right? So dear students, what is the first step? You have to identify the nodes. Out of n nodes, you please take one node as reference node and the remaining nodes as non-reference node. In this context, this node is this point is taken as a reference node, 0th node, 0 volts, and remaining nodes as non-reference nodes. That is the first step. Now let me come to the second step. You have to apply the KCL. Nodal analysis itself means two laws, combination of two laws, KCL plus Ohm's law. You apply the KCL where you have to apply at each n-1 non-reference nodes. Very, very important. You have to apply the KCL at each non-reference nodes. After applying the KCL, now you express the branch currents in terms of the node voltages by applying which law? Ohm's law. By applying which law, dear students? By applying the Ohm's law. Right? Once you got the equations, how many equations you will get in nodal analysis? This point is very, very important. How many equations? If you want to cross check somewhere you are committing the mistake, the total number of unknown equations, the total number of equations to be solved will be how many, dear students? n-1 equations we will get. n-1. For example, in a given problem there are 3 nodes. How many equations you will get? 2 equations you will get. For example, in a problem there are 4 nodes are there. 4 nodes are there. How many equations you will get? 3 equations you will get. Now you want to solve those 3 equations. For that sake, you will get 3 by 3 matrix. To solve these 2 equations, you will write it in the form of a 2 by 2 matrix. I will tell you. We will discuss that also. But the key point is, you solve the n-1 equations. Right? So I repeat again, dear students. First step, identify, take one node as a reference node and remaining nodes as non-reference nodes. Second step, apply KCL to each n-1 non-reference nodes and apply Ohm's law to express the currents in terms of voltages, in terms of node voltages. Third step, you will get n-1 equations which are to be solved. Okay, and on solving those equations you will find out the unknown voltages, unknown node voltages. These 3 steps are very, very important. Clear? Right. Now let me apply these 3 steps and solve the problem in a step-by-step manner. Dear students, please all of you take this problem. Right? Observe. For in this problem, I have taken a current source IS1 5 amps, IS2 10 amps, and R1 10 ohms, R2 20 ohms, right? And R3, how much? R3 30 ohms. See here, you take a reference node. What is our first step, dear students? Focus, please pay attention, please pay more attention. you take a reference node and you assign node voltages to the non-reference node, and also you indicate the current directions in the each branch. You indicate what you have to indicate, current directions in the each branch, and you please redraw the circuit diagram in the question, in the answer sheet or in the notebook. You please redraw the circuit diagram, right? So in this problem, number of nodes are how many? 3. Number of nodes are 3. First node, second node, and the third node. Take one node as reference node, remaining 2 nodes as V1 and V2. Remaining 2 nodes as V1 and V2. On the examiner who evaluates your paper, on looking at the first step itself, he will get impressed. The first, it's not a rule that you will get full marks if you get only the final answer. In this, while doing such kind of problems, for procedure itself, you will have marks, whether the student has followed the procedure or not. Even though sometimes you may not get the exact right answers. For example, if it is given for 8 marks or 16 marks, out of 8, you may easily get sometimes 6 marks if you follow the procedure. It's not a rule that you should exactly get the answer. Of course, you should get the answer, but don't think that if you got the answer, then only full marks will be awarded. No, paper evaluation or the evaluator who evaluates your paper will not look like that. The moment he sees, yes, the student has indicated the node numbers, and he has indicated the current directions, and he has indicated the reference node, for this diagram itself easily can get for 8 marks, 2 marks will be awarded, no doubt. He gets the impression, yes, the student has tried solving this problem. So for this diagram and for writing this KCL, all these things itself, minimum marks will be awarded, right? The moment you see the nodal analysis problems, don't try to skip away the problems, right? Yeah. So dear students, please observe, this is node 1 you have indicated. You should read the circuit diagram in the question answer sheet or in your notes. V1 is indicated, V2 is indicated, and the current flowings, let this current flowing be I1 and this current be I2. You can take, if you are interested in ABCs, you can take IA, IB, IC, that is also up to you. If you are interested in taking node numbers as ABC, VA, BB, some people will consider it as VA, BB, and some people consider currents as IA, IB, IC, like that. That is also up to you. Not a problem, right? Yeah. Step 2. Apply KCL at each non-reference node. Now we have indicated the node numbers, we have indicated the voltage variable names. Now apply KCL. Apply KCL here. What is the entering current? IS1 equal to I1 plus I2. Very simple. At this node. Clear. Now observe in R1 is like this. Very important. Please focus, dear students, please focus. This is at 0 volts, and this node already here you have indicated it as, what is the voltage here? V1. Now R1, what is the current flowing through this one? I1. Now if somebody asks you what is I1, what you will take? One end the voltage is V1. What is the voltage difference? Very important. This is where most of the students will commit the mistake. At one end the voltage is V1. At the other end of the resistor, what is the voltage? 0. This is the voltage difference divided by, what is the current? What is the resistor? I1 equal to, divided by R1. But instead of writing every time 0, what people will do, directly they will write V1 by R1. That is the meaning. Very important, dear students. If you understand this basic, so many confusions will be erased in your mind. Now tell me, here you are having a resistor like this, and at this point the voltage is V1, at this point the voltage is V2, and you are having some resistor R2, and now I want to find the current I2. I2 direction is from V1 to V2. Clear? Now if somebody asks you what is the value of current I2, what you should write? We have to consider the voltage drop across R2. That is important. That is where most of the students are committing the mistake. Now what will be the voltage across R2? It is the difference V1 minus V2 divided by R2. If you understand these two basics, then there is very less number of mistakes will occur. Understand this basic. A resistor is there like this. At one end the voltage is V1. At the other end the voltage is V2. If somebody asks you what is the current, then your answer should be confidently V1 minus V2 divided by R2. Very clear. If arrow direction is like this, from V2 to V1, then you can say V2 minus V1. Look into the arrow direction. Don't neglect the arrow direction, dear students. Very important. The arrow direction is from V1 to V2. That is the reason I have written V1 minus V2. If arrow direction is from V2 to V1, then I might have written V2 minus V1. Keep that point in mind, right? Yeah. Now here at this point V1, and here the voltage is 0. Now what will be the value of this current? V1 minus 0 divided by R1. If you are very clear with these two basics, you can solve so many problems, right? Yeah. Now let me go here. We have applied the Ohm's law. What about I1? I want this current I1. I1 equal to V1 by R1. Why? Because here the voltage is V1, here the voltage is 0. V1 minus 0. Instead of writing 0, directly we will write V1 divided by R1 plus. What about I2? I2 here, observe, I2 is flowing through R2. At R2, what is the voltage drop? One end is at voltage or at potential V1. The other end of the resistor is at potential V2. So you should write V1 minus V2 divided by R2. If these two steps are correct, then easily you can solve the problem. Right? Now remaining part is very easy. At the intermediate level you have done all these things. Finding out solving the two equations, or solving a 2 by 2 matrix, or finding out the inverse of a 3 by 3 matrix. At in our intermediate stage itself we have done these all those things. But I will explain you. I will explain clearly step by step what to do. Right? Yeah. So first step is completed. Apply KCL. Apply KCL at node. That is sum of entering currents is equal to sum of leaving currents. IS1 equal to I1 plus I2. Now apply Ohm's law to express current in terms of node voltages. Solve this equation. Substitute the values of R1 and R2. You will get V1 3V1 minus V2 equal to 100. 3V1 minus V2 equal to 100. Now let me redraw the circuit. Now I have to apply KCL at node 2. At this node, this is the second node. Entering current is IS2 is entering like this. I2 is also entering, but I3 is leaving. So IS plus I2 equal to I3. Entering current is IS2, source current, second source, plus I2 equal to I3. Same now. Again apply Ohm's law. IS2 is given. How much? IS2 is 10 amps. Equal to, what about I2? Just now I told, look into the direction of the arrow. I2 is from, this is resistor R2. Here the voltage is V1. Here the voltage is V2. The current is flowing like this, I2. Now somebody asks the current value I2. It is simply V1 minus V2 by R2 equal to, what about R3? For R3, one end the voltage is V2, the other end the voltage is 0 volt. So V2, its meaning is V2 minus 0 by R3. V2 minus 0 divided by R3. These two equations important. Clear? Right. Now remaining things same. You just simplify that. 10 plus V1 minus V2 by 20 equal to V2 by 30. You bring this V2 by 30 towards left hand side. You take out the LCM, and you will get one more equation like this. 3V1 minus 5V2 equal to minus 600. Now how many equations we got? Two equations. How many nodes are there? Three nodes are there. How many unknowns are there? Two unknowns are there. We have to solve those two unknowns. We have to solve those two unknowns. These two unknowns, solving 1 and 2. On solving 1 and 2, 3v1 minus v2 equal to 100, 3v1 minus 5v2 equal to minus 600. Let me solve these two, dear students. You will get v2 as 175 volts, but 3v1 equal to 100 plus v2, and we will get v1 as 91.66 volt, 91.66 volt as v1, and v2 as 175 volts. This is how we can solve the problem. Okay. Now let me see how to solve those two equations using another method. Now we have directly solved that. Using another method, 3v1 minus v2 equal to 100, and 3v1 minus 5v2 equal to minus 600. Write it in the form of a matrix, in the form of some ax equal to p. v1 coefficient is 3 minus 1, here the coefficient is minus 1, and for the second equation the v1 coefficient is 3 and v2 coefficient is minus 5, and v1 v2 equal to 100 minus 600. This is in the form of ax equal to b. Now what about x, dear students? X equal to a inverse into p. If you observe, A is a 2 by 2 matrix. A is a 2 by 2 matrix. What is its variable? What are the variables? A, B, C, D. A, B, C, D. Now we know what is the A inverse of a matrix A, B, C, D? 1 by AD minus BC, and you just write D here and A here. And for B and C you have to change the signs. This is where most of the students will forget to change the sign of B and C. They will interchange D and A, but they will forget to change the signs of B and C. 1 by AD minus BC also they will write correctly only in their paper. 1 by AD minus BC also they are writing correctly, but they are forgetting to place the negative signs. That mistake please don't commit, right? Yeah. Now 1 by AD minus BC bracket of D minus B minus C minus A. So like that you will find out the A inverse. Once you know the inverse, now it's a simple multiplication. It's a multiplication of 2 by 2 matrix with 2 rows, 1 column, right? Now this multiplication is possible, right? Because some m by n matrix multiplication with some n by k, n by 1, you will get a matrix of some m by 1, right? Multiplication is possible. How we will multiply that? See here, these two elements, first we will multiply with these two elements, that is 5 by 12 into 100, very important, plus minus 1 by 12 into minus 600, minus 1 by 12 into minus 600. First row is completed. We will repeat the same multiplication for second row. Second row is this one, 3 by 12 into same 100, 3 by 12 into 100, this, and this 3 by 12 into 100 you will multiply, and this into this one will multiply, right? Minus 3 by 12 into minus 600, very important. Here you should take the plus. Just on doing simplification with the calculator, you will get 91.66 and 175. In the two ways we have solved this problem, two equations. One more thing is, you can take your calculator. In the first year level you will use this calculator during exam, okay, and you can press this mode button 2 times, 3 times, 3 times I have pressed, and there you will get equation mode 1. If you press 1, you will go into the equation mode in calculator, and it will ask you how many unknowns are there, In our problem, the unknowns are how many? 2. Unknowns are how many? 2. We will enter 2. It will ask for A1 value. A1 means in this context the variable, the coefficient of V1. What is the coefficient of V1? What is the coefficient of V1? 3. Next it is asking for B1. A1, B1. B1 means the coefficient of V2. What is the coefficient of V2? -1. Now it is asking for C1. So C1 means 100. A1, I will write here. In calculator, unknowns A1, B1, C1. Now we will enter unknown A2 coefficient, B2, C2. Then you will get the final answer in one step in calculator. So 3 different ways. C1 is how much in this context? 100. What is A2? 3. B2 is -5. C2 is -600. So you will get in terms of x and y. In our context, x means V1, y means V2. So directly you will get 91.66. And again, if you press equal to, you will get y. Y means in our context it is V2. Like this. Using this calculator also, the simple. If you press the mode, reset the calculator. If you press mode in FX 991 MS model, FX 991 MS model, if you press 1, 2 twice, you will get equations mode. You go into the equations mode and you solve that. Okay, that is the third way. Now let me discuss one more example. See, dear students, we are increasing the level of difficulty. In this problem, you can observe there are 3 nodes. If a problem is given like this, okay, the step 1 is we will indicate the nodes. This is one node, V1. This is another node, V2, and this is the third node, V3, and this is the fourth node. Out of these 4 nodes, we are taking one node as a non-reference, one node as a reference node. So this node is taken as a reference node, this 0 volts, and I will indicate it as a 0th node. The voltage at that node is 0 volts. The voltage at that node is 0 volt. Right? Now for remaining nodes, indicate the node voltages. This is V1. This node is the second node. Indicate node number as V2, and this is the third node, V3. And you indicate the branch currents, the currents flowing in the branch. Indicate the branch currents. Current flowing through R1, let it be I1. Current flowing through R2, I2. Current flowing through R3, I3, and through R4, I4. This is up to you whether you follow A, B, C, D or 1, 2, 3, 4 based upon your convenience. You can decide. And arrow directions also, it's up to you. It's not a rule that you should take like this way. If the direction at the end you may get some, if it is opposite you have taken, you may get negative answers. That's the only difference. Okay, yeah. So this, on looking at this diagram itself, you will get some marks, right? What are those? Indicate the node numbers V1, V2, V3. Indicate the branch currents I1, I2, I3, I4. Indicate the reference node. Step 1 is completed. Clear. Go to step 2. Simple. Apply KCL. That's it. You don't bother much. You just simply apply the KCL. Sum of the entering currents equal to sum of the leaving currents. Go KCL at node 1. What is the current entering? IS1 is entering. What are the currents leaving? I1 is leaving, and also I4 is leaving at this node. We just focus only at one node at a time. Enough. IS1 is entering. Over. Very simple. Entering current equal to leaving current. Now apply Ohm's law. you don't forget this basic. If you are having a resistor like this, if here the voltage is V1 and at the other end the voltage is V2, if current is flowing like this and this is a resistor R, I equal to, I will be how much? V1 minus V2 by R. If you are having a resistor like this, the other end is at 0 volts, but here it is at some V2 and some current, for example I is flowing, and this is some resistor R, then your I will be V2 minus 0 divided by R. If you understand these two basics, then you can write Ohm's law correctly. Right, that is what we will do here. I1 is how much? Diagram is not visible. I1 is, at this node the voltage is V1, at the other end the voltage is V2, so I1 V1 minus V2 by, what is the resistor value? R1. Very simple. What about I4? At this node, for R4, at this node the voltage is V1. You observe it is came up to here. At the other end the voltage is V3. The voltage is V3. That is the reason V1 minus V3 divided by R4. Very simple. You solve it. Take out LCM. Substitute the values of R1 and R4. R1 is 10, R4 is 40. So 10 equals to 4V1 minus 4V2 plus V1 minus V3 by 40. If you write it in the form of equation, you will get like this. First equation. Now apply KCL at node 2. KCL at node 2. This is the second node. At node 2 you can observe, at this node one current is coming like this. What is that? I1. The other current is also coming like this. What is this one? I2. One more current is there. One more current is leaving like this. What is this current? I3. Now at this node, if somebody asks you KCL, what is the basic rule? Entering currents equal to leaving current. What are the currents entering? I1 plus I2. I1 is entering, I2 is entering. Or equal to I3. Clear. Now what about I1? At this point the voltage is V1. At this point the voltage is V2. At this point the voltage is V3. At this point the voltage is 0 volt. Now your I1 will be how much? V1 minus V2 by R1 plus I2 is how much? Observe the direction of I2. Here immediately I2 is asked. Most of the people may write V2 minus V3, then problem goes wrong. Direction of I2 is important. I2 is from V3 to V2, like this it is there, V3 to V2. So V3 minus V2 by 20, and you bring that I3 towards left hand side, minus V2 by 30 equal to 0. If these steps are correct, see, analysis part 2 by 2 matrix or 3 by 3 matrix solving, students are doing it correctly only. We have seen most of the students are finding with the help of calculator or with the help of intermediate basics, they are doing that correctly only. But the problem is deriving those unknown equations. First of writing those unknown equations in the form of a matrix. After writing in the form of a matrix, they are solving it. V1 minus V2 by 10 and V3 minus V2 by 20 minus, we bring it in the form of equation. Right. Next, at node 3, KCL at node 3, same, IS2 plus I4 equal to I2. Apply the Ohm's law. 5 plus V1 minus V3 by R4 equal to V3 minus V2 by R2, and you will get one more equation. V1 plus 2V2 minus 3V3 equal to minus 200. Now our target is to solve these unknown equations. What are these unknown equations? 3 equations we got. What are those? This is the first one, second one, third one. Write these equations in the form of a matrix. You write in the form of some Ax equal to B. What is the first coefficient, dear students? First equation coefficients are 5, minus 4, minus 1, V1 times equal to how much? 400. Now what about second equation, dear students? Coefficients 6, 6, 6, minus 11, minus 11, and 3. Polarity is also important. Sign minus 11 and 3. V2 times equal to 0. What is the third equation? V1 coefficient is 1. 1. V2 coefficient is 2. And V3 coefficient is minus 3. Equal to minus 200. So expressed in the form of a matrix. Right? Observe, dear students, finding out the inverse of a 3 by 3 matrix using this method easily you can do it. That is, first row first column, first row second column, first row third column. A second row first column, 2 2 2 3. Third row first column, third row second, third row third column. Like this, if matrix A is there, then it's a determinant. What you have to do is you just repeat all the first two rows. See here, in the form of determinant, like write first 3 rows as it is, and you repeat the first 2 rows. A 1 1, A 1 2, A 1 3, and similarly the second row also you repeat A 2 1, A 2 2, A 2 3. Now the determinant is very simple. What you have to do is you multiply all these 3, A 1 1, A 2 2, A 3 3. In the manner I have written the line. A11, A22, A33, and also you multiply and you add that value with like this 3 terms you get. First this side, from right to left multiplication you add all those elements. The second is A21, A32, A13. You multiply these 3. The third set is A31, A12, A32. Very simple. In the other side, from other side, now you multiply so right to left these terms. A13, A22, A31. But the thing is you have to take minus sign. Minus of this, you multiply A13, 22 and 31, and also you multiply A23, 32 and A11. A multiply, but you have to take minus sign. Similarly multiply these 3, A33, A12, A21. Again you take minus of that. If you do like this, you will get the determinant very quickly. But here it is in terms of A. It may look little bit complex. If numericals are there, very quickly you can do the determinant. But if you follow this matrix, this type of finding out determinant, then it will be easy for you. Okay. So here. So dear students, first delta. For delta, let me find out the determinant. 5 minus 4 minus 1, 6 minus 11, 3, 1, 2 minus 3, 5 minus 4 minus 1. You just repeat the first 2 rows. First 2 rows are to be repeated. 6 minus 11 and 3. Now let me simply multiply this. 5 minus 11 minus 3, 165. 6 into 2 into minus 1. Very fastly you can do. Minus 12. 1 into minus 4 into 3, minus 12. Right? All these values add up. Pause. 165 plus of minus 12 plus of minus 12. Now come to this side. Minus 1 into minus 11 into 1. minus 1 into minus 11 into 1, you will get 11. 3 into 2 into 5, 3, 2, 5, 30. Minus 3 into minus 4 into 6, 72. Important thing, don't forget minus sign, minus. So minus 11, minus 30, minus 72. Now the determinant value is 28. Clear? So far clear, dear students? This is how you can find out the delta. This is how we can find out the delta, right? Yeah. Now with respect to delta 1, what we will do? We will replace the first column with this 400, 0 and minus 200 we will write to find out delta 1. Why? Because in order to get V1, what will be our V1? V1 equals to, see here, delta 1 by delta. V1 will be delta 1 by delta. V2 will be how much? Delta 2 by delta. And V3 will be delta 3 by delta. Now let me find out delta 1. Just replace the first column with 400, 0 and minus 200 in the form of matrix AX equal to B. You replace the first column of A with B, right? Now to find out the delta 1, same, repeat the procedure. We have repeated the last first two rows again, and you do the multiplication. You will get 15,400 as delta 1, right? Similarly, find out delta 2. While finding the delta 2, what you have done? You have replaced the second column. You have replaced the second column, right? So here delta 2 is 600, delta 3 is 15,400. 15,400. After finding out these delta values, now let me see that delta is 28, delta 1 is 15,400, delta 2 is 12,600, and delta 3 is 15,400. Therefore V1 equals to delta 1 by delta. 15,400 divided by 28, 550 volts. V2 equal to delta 2 by delta. 12,600 divided by 28, 450. And V3 equal to delta 3 by delta. It is 550 volt. So far clear, dear students? Once you have found these values, now you have derived the node voltages. Very, very important. Right? Now let me do one more small simple example. Calculate V3 by applying nodal analysis. This is node 1, this is node 2, and this one as node 3, and we have taken a reference node. This is at 0 volts, this is at 0 volts, right? V1, V2, V3. That is now I am not writing here, as it is the last example. I am not writing all the 3 steps. Directly we enter into the problem. Step 1, what is that? We indicate the node numbers, indicate the branch currents. That is step 1. What is step 2? Apply KCL. Can you apply KCL at this point? No, not required. These two are in series. Can you apply KCL at this point? Not required. These two are in series, right? So what is the current entering at this node? At node 3, node 3, I1. This circuit is where most of the students will do the model calculations in their laboratory. while applying for the theorems, Thevenin's theorem or Norton's theorem, or for superposition theorem. Okay, they are supposed to do the model calculations just before attending the lab, right? So apply KCL at node 3, I1 plus I2. This current is entering, I1 is entering, I2 is entering, equal to I3. Simple. Apply Ohm's law. What about I1? For this resistor R1, at one end the voltage is V1. This point is important, dear students. V1. The other end of the at the other end of the resistor R1, the voltage is V3. So because of that, observe, if this is the resistor R1, here the voltage is V3. Okay, good. But here the other end is at plus V1. So this voltage is at what? V1. Now if I want current through here, I1, now it is simply V1 minus V3 by R1. Similarly I2. For I2 resistor, observe, resistor R2 is there like this. Here the current is entering like this, I2. The voltage at this node is V3. Okay, good. This is resistor R2. But what about the other end voltage? This is connected to a voltage source, positive, negative, V2. So this other end is at what voltage? V2. But the current direction you observe, it is from V2 to V3. So I2 will be how much? V2 minus V3 whole divided by R2. That is what we have written here. If these two steps are correct, then it will be very easy for you. Now this I2. Consider for the resistor what are the voltages at the both the ends and what is the direction of the current. What is the direction of the current, right? I3 is very simple. I3, why? Because I3 resistor R3 is there like this. For resistor R3 at one end, what is the voltage? V3. At the other end, it is at ground, 0 volts. Now current is flowing like this. So I3 will be how much? Obviously V3 minus other end is 0 whole divided by R3. V3 minus 0 divided by R3. So on solving this one, you will get an equation in terms of V3, and now your V3 is 16.36 volts. Only one voltage, one thing only you are supposed to find out, V3, right? Now once you know V3, easily you can calculate the value of I1. What will be the value of I1? V1 minus V3 by R1. V1 is already known, 24 volts. V1 is already known, how much? 24 volts minus 16.36. Just now we have found V3. 16.36 divided by 10. So the current I1 is 0.764 amps. What about I2? V2 minus V3 divided by R2. Why only V2 minus V3? Because observe the direction, it is from V2 to V3. So V2 minus V3 divided by 20, you will get minus 0.218, right? I3 V3 by R3, you will get 0.546 amps. So this is what all about the nodal analysis, dear students, which is a very important topic in the entire DC circuits unit, and this is the topic where most of the students will face the difficulty. And if you don't understand, once again you please watch the basics once again, and if any doubts are there in regarding this topic, below this video you can simply comment your doubts, and I will look into those comments and I will solve your doubts. If still you are having any doubts with respect to this topic, okay, you can send me those doubts. We can interact and we will discuss those doubts and I will solve your doubts. But my aim is every student, if any problem is given from nodal analysis, they should not feel that much difficulty to attempt that problem, right? These are some of the important basics. Of course we are not going discussing the the same nodal analysis with some dependent sources, okay, and with some AC analysis, although just with simple DC. In the DC circuit analysis, we are discussing the basic simple steps, and here all the sources are independent sources. Yeah, any voltage source, I have not taken any dependent source. Of course, for example, there is a of course not required as per your syllabuses, you are not having, but if any of you are having or if any one of you want to learn the same nodal analysis with some dependent sources, you can comment in the comment box below this video, so that some examples will be made on that dependent sources also, considering the dependent sources also, and it will be uploaded shortly, right? But I don't think most of the colleges don't have. For electrical engineers, in electrical circuit analysis, they will have that nodal analysis with again with dependent sources, right? Thank you.